Here we are with the Unit 6 full overview. So I started with the timeline of the year so you can see the patterns that are spiraling. And then I'll actually go to the next slide to take the deeper dive into all of the performance expectations. So this is our culminating unit. So Unit 7, we've already talked about possibly you can be chopped up and fit in various places. Look at all these performance expectations from physical science around electric motors and generators, defining design, build, and refine a device that converts one form of energy into another, engineering, technology, and society ones, evaluate solutions to a complex real world problem based on prioritized criteria, earth space science, use model to describe variations in the flow of the earth. There's just so many. I won't read all of them, but this is an important unit. Okay, so here we are on the website and you can read deeper. Again, lots of assessment opportunities, and these are really assessment for learning. So formative or summative, but worth doing. Even if they aren't going to end up in the grade book, assessment for learning. All right, so what is this one about? So students are put on the Energy Plan Commission and need to come up with a 50-year energy plan. And of course, that turns into the essential question for the unit. How does STEM inform our future? Okay, so with that, here's the 45-second overview of the whole unit, and then we'll dive into each task. All right, so they are introduced that pretty early on. And to contextualize that, the first thing we actually do is Voices of the World, where they read transcripts of interviews of people all around the world that are affected by power production and climate change. Then they get introduced to reading some excerpts from the actual biennium plan. And all portfolios always need a little background physics. So that justifies us going into how generators work. But of course, we got some other physics targets that we want as teachers. And it's pretty awesome because what is one of the coolest electric motors? Speakers. We just came off of the Waves unit. So it's a great connection there. They build speakers. We'll look at that. And then generators, and then make electric guitars. So awesome. But that is not enough to power the world around us. So we got to talk about scaling up and engineer a wind turbine. That also has an engineering slice around solar power. And of course, these are the two fastest growing energy production means in the United States and possibly, I think, worldwide. So with that in mind, to finish it out, they need to do some evaluation of the climate impact of these various power production means. And that justifies the deep dive into all the Earth space science targets that we have in this unit. And then they put it all together to do yet a new way of computational thinking. So they're not doing as much coding this time. They're literally using their human brain and a computer to rapid prototype and try out many, many different solutions to the problem. Okay, let's go a little bit deeper into each of these tasks. So as mentioned, Voices of the World, that's that excerpt. Each person takes it on. And yeah, great activity, liked by students a lot. So right after that, then they get introduced to the engineering portfolio. And I just want to show, here's the biennium report. By late this year, we'll have the 2022 report, but it actually ends up referencing the 2020 report, which also references the 2018 report. So with that all in mind, here's the charge to the Energy Plan Commission. As always, they get the problem statement, which of course they'll put on the packet, and then the constraints that are in this and the criteria. Then with all that in mind, because a lot of these things that they're reading about, they're not as familiar with, they do some background research on power production on the criteria 1, 2, and 3 that they come up with. But again, they typically are around the environment, economic or cost, and climate impact. And so there's a great website that leads them through that. Then strongly suggested that they write the first part of their culminating 5-paragraph essay, or some teachers elect just to do this graphic organizer. But this is, in a sense, the system analysis. It provides that function. So let's get them really clear on what they're doing. So the problem statement, the constraints, the criteria, what is your highest priority? You could see that in the performance expectations based on prioritized criteria. So, different students will pick different things: environment, climate, and economic impact. And so this is good stuff. This definitely strongly encouraged to do that early to lock it in so that students really are thinking about the constraints and the criteria from the beginning. All right. And then already, as mentioned, that as they construct their final portfolio, we always give background information. Use the big ideas of science to explain how things work. So that's what they're going to do here. But as physics teachers, we not only want them to understand generators, we want them to understand motors. So we actually start with the motor first, and they make speakers. And here's just a short video. I'll play it just for a second. That is in the slides. And you can only hear the speaker part for about the first couple seconds.
Okay, here we have a speaker, which is really an electric motor. We're using electricity coming out of our player, going through a wire, and I have a permanent magnet for it to push off of. A speaker is a motor. So if we run this backwards, this is electricity into motion. We run this backwards, we should get motion into electricity. And then of course we'll do electricity back to motion with this speaker. But let's check and see if I can make a microphone, which is a generator taking motion into electricity. 1, 2, 3, 4, 5, 6.
Okay, so short and sweet. It's not an amazing video, but it does get the job done. It shows you that simple, $1 speaker, and they sound pretty good. Great activity, high interest, and that even shows the generator. But again, we want them using the big ideas of science to explain phenomena, how things work. So that video didn't attempt to teach it. That's not the purpose of that video. All right, so in any case, though, here is one of the things that they do. So they got an annotated real-world picture of what's happening with the electromagnet, permanent magnet, and a music signal, description in words, and energy bar chart. So they're using the tools of science to learn science. All right, so we were interested in the generator, which you saw some of students like making the microphone, and that's pretty cool. But here is, again, just a short video on, let's take those acoustic guitars and turn them electric. Real short video.
Oh, yeah. It's supposed to be.
Okay, here is the magnet. We got our coil sandwiched underneath there, and just 2 wires going into our.
Okay, so again, that shows you the $3 electric guitar. Super awesome. Moving a magnet near a coil of wire. So changing magnetic field produces an electric field. Great stuff there. Okay, so just a little peek at how they do it. And again, using the tools of science to learn science. All right, moving on, just want to say that there is connections throughout the unit to all of this real world. So this happens to be a interactive map that you can see all of the power production sources in the Western United States. Super awesome. And you can zoom in all the way down and look right around your school. Great resource. And I'm not going to show all of those. So this is really the only one, but just want to say throughout this unit, there's things sprinkled in like this. All right. So as mentioned, electric guitars, as cool as they are not going to power our energy needs. So we got to talk about engineering and scaling up and having large power production scales. So wind turbine, no surprise there, but I want to show a couple things that are possibly unique or just you might not know about. So again, you just see this cross-cutting concept of energy and energy flow and analysis through the system. Students have really developed that over the year. So system analysis. All right. And then the other thing is, because students tend to vary the same things, here's a real chance to assign them. So someone might have angle, someone might have size, someone might have number of blades. And they see how that affects the power output. And that, of course, is talking science. They're looking at how size of blade affects power output. Then in light, so they talk science, they jigsaw, as we do with so many of our experimentation. But then in light of trade-offs and costs, they have to talk engineering. How do they maximize within their budget the power output of the wind turbine? Then we have an engineering slice. It's not full scale around solar power, and just a great phenomena-based question. Why are solar panels mounted this way in the Galapagos? Here's a picture of an Oregon installation, and then Alaska. So great hook. Students have a lot to say about it. Go right into it, and also get introduced to a new pattern beyond the 4 that we have talked about. Then, so now we've mapped out how generators work. We've looked at large scale generation. I showed you that peak of that background research. They never did research the climate impact. So that justifies us taking a deeper dive into all those earth science targets that we wanted to go. So they go and look at, what affects climate on Earth. And specifically, there's roughly 10 that are called out for in the NGSS. And so we look at all 10. Great activity for that not quite a station, but stations like. All right, and then with that deeper dive with all those earth science targets and looking at climate change data, they put it all together and do a new form of computational thinking. So let's take a peek at that. Really, green is the go input. So they start with the 2010s. It's shown what happened. Each power source has, after consultation with Bonneville Power Administration, Bonneville Environmental Foundation, was able to talk with people at the Oregon Department of Energy, putting these numbers. There's also a link to some general resources around those. All right, so they kind of each have their Pokemon stats. So their land use, their climate, their lifetime cost. And then they have to, again, meet the constraints. They have to provide enough energy. There's only so much change that can be handled. And then there has to be reliability. So as they invest heavily in solar power, the reliability drops, and they must invest with energy storage and smart grid technology, one or other or both. And then, of course, they also have a land use environmental impact, a climate air quality impact, and a lifetime cost. And then also a new addition, if you haven't seen it recently, is the total score of all 3 criteria. So they don't just focus on one and let the other ones be neglected. All right, and then another nice little touch now is they produce their own Sankey diagram of that 50 years. All right, and then that culminates with that 5-paragraph essay. They've already written, and this is claim, evidence, reasoning, right? So again, vertically articulated throughout the year. This is quite advanced. The claim is no longer a single sentence. It's actually 5 sentences. And then the evidence is their plan, and a competing plan that ideally is another student's plan or a plan provided by the teacher, depending on exactly how you want to run that. And then the reasoning about the best design, and then the limitations of your plan. This is straight out of the evidence statements of all of those performance expectations we talked about. So here is just, again, you can see the key, and you can look at a very exemplary one written by a student. Just amazing. That's not always the right fit though. So it's many, how do we get students to write this? Here is a graphic organizer, and there's of course also a leveled support for this that I'll show where it is in just a second. But say, some teachers, this is the right fit for them. So having students complete this is, guides them through to really think about those competing plans. And here's that support with the sentence stems and graphic organizer. This is also a day that you can invite people in. Having students present their plan has been very rewarding for students. So having adults come and listen, then of course also you can have those adults share their own professional experiences too. And that's great, especially after they've listened. Students take a lot more interest in there. All right, that is the wrapping up of the overview of